Good morning and good day, everyone. Once again, my name is Tony. I'm a course advisor at EIT, and I will be your host for today's webinar. And thanks for joining me. Can you please just confirm if you can if you can hear me and you can see my screen on the chat? Okay, perfect. Well, I think most people can hear. Okay. Then we can begin with the webinar. Before we begin with the webinar, I would like to cover some few notes. So on your screen now is the notification and sound. So you are able to turn on and off the notification sound as you wish during the webinar session. Please post any questions under the Q&A function at the top right hand corner. You will see on the three dots, you are able to post your questions there. So if the questions are technical, our presenter will be able to assist regarding that during the Q&A session. And if the question has to do with the course offering at EIT, I will be able to assist you with that on the chat box. Okay. Moving right along. So these are some of the common questions, frequently asked questions. So everyone registered for this webinar will receive a copy of the PDF slide and a link to a video recording within the next 2 business days via an email. So please do check your junk folder, spam folder, if the email does not appear in your inbox. And we also provide a free certificate of attendance at the end of the webinar. So we will give you a QR code and a link that I'll be sharing on the chat box. So at the end of the webinar, you can claim your certificate via the QR code or the link that I'll be sending it to you. Just a little information about EIT and ECT, apologies. So the Engineering College of Technology is based in the UK, United Kingdom, and the Engineering Institute of Technology, EIT, is based in Australia. So both of the institutions specialize in engineering and technology, but they focus exclusively on engineering and technology programs. Both offer industry-focused expert-led courses are built by global experts and delivered by experienced engineers. Global recognized, the ECT offers UK recognized qualification, while on the other hand, the EIT provide Australian accredited qualification, many which are recognized under the Global Engineering Accord. Both institutions also offer a range of professional development courses, and both of the institutions actually have an innovative, engaging, and practical online learning approach with a cutting-edge tool facilitate live webinars and access to a remote labs and simulation. We also offer a personalized student support. That would be our learning support officer that do assist our students throughout the program. We're also a part of a global learning community with students member of faculty based across the globe. We offer accessible high quality education at an affordable price. Let's move right along. Ladies and gentlemen, a disclaimer. The courses and qualifications mentioned in the presentation are offered by separate legal entities operating in different jurisdictions. One in Australia, one in the United Kingdom. Each entity is subject to its own local regulatory requirement and accreditation standard. Prospective students should refer to the relevant institution official website for accurate, up-to-date information specific to their location, including a course availability, fees, regulatory status, and enrollment conditions. So below are some of the links where you'll be able to view some of the programs offered by the respective institution, EIT and ECT respectively. So I'll also be sharing the links on the chat platform. EIT as well as ECT also offer engineering group training packages for companies. We believe in empowering technicians and engineers with the practical industry level relevant skills. So if you want to learn more about this, you can check our product managers details on the screen now. That is going to be our product manager, Cameron Gill. So this is his email address. You can take it and send him an email if you want to learn more about engineering group training. Well, today's topic is generative AI in industrial automation, which will be presented by Dr. Krutika Ramesh, AI engineer at Studio City, an academic lecturer and also tutor. Dr. Kutrika,
Yes.
can you
Am
hear
I
me?
audible?
Okay, you are audible. Yes, you can take control.
Yeah, thank you for the introduction. Um, Hello everyone, and thank you for joining today. I'm Dr. Kritika Shahabatkar, an AI engineer and a researcher working at the intersection of machine learning, Gen AI, and real world systems. So, my work focuses on building end to end AI solutions across various industries. So, in particular, I specialize in integrating large language models like GPT, Gemini, um, Claude. You might have heard of Mistral, and all of these models with tools such as Retrieval-Augmented Generation and real-time sensor data to create intelligent systems. Basically, that makes decision making more informed in much more complex environments. So, I worked on several projects involving smart factory workflows, edge AI deployments, and bridging advanced AI with practical needs and all of that. Beyond engineering, I teach postgraduate courses in AI and machine learning, and I'm passionate about building responsible ethical AI systems that can scale in low resource and high impact settings. So I'm excited to share insights today on how Gen AI is transforming industrial automation and how we can build systems that are not only intelligent but are also truly usable. So today's agenda, we're going to start with introducing. Uh,
Apologies, Kritika. I'm so sorry to be so here. Could you kindly take control of the slides, please?
okay. I have the control of it. Like I'm able to navigate backward and forward.
I think you are navigating the slides. However, did you click on take control?
Not yet.
Please.
Mm-mm. Okay.
Thank you very much. The slides are moving now.
All good. Okay. So today's agenda is going to be introducing generative AI, seeing what's the difference between traditional and the generative AI, then key concepts in Gen AI, use cases, quality control, predictive maintenance, challenges, and future trends. So let's begin by understanding what generative AI, or as popularly called as Gen AI, is and why it matters. So, Gen AI has revolutionized how industries approach problem solving and innovation. Unlike traditional AI, which mostly classifies or predicts, generative AI creates. So it generates new content, ideas, and solutions. This capability opens new doors for automation and operational efficiency across many sectors, especially industrial automation. Now let's see how Gen AI has evolved in industry. So, in industry, we've seen rapid adoption of generative AI technologies. For instance, in 2023, AI-driven predictive maintenance systems started launching in factories. By 2024, AI improved supply chain optimization through smarter analytics. Then, looking ahead, we anticipate autonomous robots on assembly lines by 2025 and full AI adoption for real time decision making by 2027. This timeline illustrates not only the pace but the breadth of AI integration into industrial processes. So, to put this in perspective, AI's evolution began around 2010 with early algorithms. Deep learning techniques gained traction by 2015, and 2018 saw the launch of generative adversarial networks, popularly called as GANs, which are central to Gen AI's power today. So these milestones have shaped how industries harness AI for complex tasks like quality control and predictive maintenance. Now let's talk about the fundamental shift we are witnessing in artificial intelligence. So traditional AI has been around for decades. It's your go-to for things like predictions, classifications, optimizations, right? The kind of AI that crunches numbers and tells you whether a machine will fail or not. So think of it as a calculator on steroids, efficient, reliable, but not particularly imaginative, right? So now Gen AI, this is where things get really exciting. So rather than just analyzing data, it creates. So it generates new content. It can be text, images, audio, video, coding, anything. And it's not just mimicking, it's synthesizing, combining information in novel ways. So, under the hood, generative AI uses complex models like GANs and transformers, which thrive on massive unstructured data. Stuff like images, videos, sensor data, or even free-form text. Let's not ignore the compute demands. So these models aren't light. So they often need dedicated GPUs or TPUs to run efficiently. So that's why cloud-based infrastructure has been a key to this transformation. What's even more fascinating is how humans have been able to interact with Gen AI. So instead of passively waiting for results, users co-create. So you prompt, then the AI responds, and then you iterate, and it's a loop, right? And what do you think the best part is? So it is this interaction that breeds creativity. But with great power comes hallucinations and ethical challenges. So we'll get to those. For now, just know Gen AI isn't replacing traditional AI, it's potentially expanding what's possible. Now, why Gen AI? So, why has it gained so much of momentum? Because it drives efficiency and innovation, and more than half of the companies are integrating AI technologies today, as you might have seen, and you can see up to 30% of reduction in operational costs. So it streamlines processes, accelerates product development, and enhances decision making, particularly in uh, industries like manufacturing, where speed and accuracy are critical. As you can see in this figure, so they predict the manufacturing market size of AI from 2023 to 2034. You can see that it was about 4 billion US dollars at 2023, and it could potentially reach of about 230 billion US dollars, which is huge. Okay, so that was a bit of background on Gen AI, its journey so far, and all of that. Let's come down to starting to understand the key concepts in Gen AI. So, first up is variational autoencoders or VAEs. So, these are like compression artists. So, they take complex data, say images or sensor readings, and compress them into a smaller, more manageable form while still preserving the most important features. Then they can reconstruct that data or even generate variations of it. Imagine feeding it designs of a turbine blade and then asking it to create entirely new but viable blade shape optimized for different environments, right? Then we've got generative adversarial networks, popularly known as GANs, and this is where things get spicy. So think of it as a game between two AIs, a generator that tries to create fake data and a discriminator that tries to catch the fakes. So discriminator is more like the traditional AI and the generator is using Gen AI. So over time, the generator gets better and better until its fakes are nearly indistinguishable from the real thing. So that's how we get hyper realistic images, synthetic data sets, or even AI generated videos of product failures that might we that would have never actually happened, but help us prepare for them. And finally is reinforcement learning. So this one's inspired by how humans learn. How do we do that? Trial and error, maybe? So you set an objective, then the AI takes action, it gets either rewarded or penalized, and then gradually learns the best strategies. So, in an industrial context, think about robotic arms, learning to assemble components more efficiently, or AI systems optimizing energy consumption in a plant based on fluctuating load. So these concepts are not just academic concepts, but they are the engine behind today's smartest industrial systems. So let's make this real, right? How exactly is Gen AI showing up on the factory floor, in the control room, or across your supply chain? First up, predictive maintenance. So we've been doing predictive analytics for a while, but with Gen AI, we now have models that can simulate equipment behavior under unseen scenarios. So imagine not just predicting when a pump might fail, but understanding why it's degrading and simulating potential fixes before they even happen. Then there's quality control. So instead of relying on just fixed rules or visual inspections, generative models can learn what a perfect product looks like. And then it can spot some deviations, even the ones no human eye can catch. And the speed? Oh, we're talking about real time image and sound analysis right on the line. And for process optimization, it's no longer about tweaking one variable at a time. So Gen AI can simulate thousands of process variations to find that sweet spot where quality, speed, and cost are all optimized. So think of it as having a digital twin with creativity baked in. So these aren't just efficiencies, these are competitive advantages. quality control. So AI automates inspections, identifying defects in products with greater speed and accuracy. The real-time analytics provide immediate insights to maintain consistency across production lines. And predictive maintenance plays a role here as well. So, ensuring equipment remains reliable to uphold the quality standards. So, AI's role in quality control means fewer errors, less waste, and ultimately better products for customers. Another critical area is supply chain optimization. So, AI uses predictive analytics to forecast demand and reduce delays. Then, smart warehousing employs automation for efficient storage and retrieval, while AI driven inventory management maintains optimal stock levels. So, together, these applications reduce waste, minimize stocks, and improve the overall flow of materials, which directly impacts the ability to deliver high quality products on time. Quality control. As you can see in this image, so step one is the image acquisition. So whether cameras, lighting, and all of that, which clicks the picture or captures the image, either in the form of an image or as a video, and then the AI processes it using some hardware and software that's required for image processing and adds a part of AI to it, and then interacts with the surrounding systems, and then there are user interfaces. It could be a tab or a mobile or a PC or whatever, and then there is logging and analytics, and then there could be supporting automation. So let's take a closer look at why Gen AI is becoming a go-to tool in quality control. So first, there's the power of AI-driven quality systems. So traditional quality checks often operate on fixed rules or human judgment, right? Both prone to error or inconsistency. So generative AI, on the other hand, is adaptive. It learns from historical production data, detects hidden patterns, and flags anomalies with incredible speed and accuracy. So this shift doesn't just improve inspection, it transforms the entire mindset around quality. One of the biggest payoffs is enhanced accuracy. So, with high resolution imaging and deep learning models, AI can pick up minute variations in surface texture, alignment, or color that human inspectors, even trained ones, might miss sometimes. So, in industries like pharmaceuticals or aerospace or manufacturing, where failure isn't an option, so this level of scrutiny is critical. And of course, we can't ignore the financial angle. So, automating these processes doesn't just cut labor costs, it also means fewer defective products leaving the facility, fewer warranty claims, and fewer expensive product recalls, right? So, AI even helps reduce waste by catching quality issues earlier in the cycle when they're cheaper and easier to fix. So, it's not just about doing things faster, it's about doing them smarter and more sustainably, right? Quality becomes a competitive edge instead of a bottleneck. Predictive maintenance. So let's talk about a topic that every operations manager, technician, and a plant engineer loves to hear: predictive maintenance, right? So this is one of the most impactful and tangible areas where Gen AI is rewriting the playbook. So instead of waiting for things to break or relying on fixed service intervals, AI allows us to predict exactly when a machine is likely to fail and act before it does. So it's like having a crystal ball for your equipment health. So when it's generative AI doing the analysis, the predictions are not just based on averages or past failures. They are based on simulations of how a machine is behaving right now. Compared to millions of potential failure scenarios, it has learned to generate and evaluate. So, this is more than just maintenance, it's a strategic foresight. All right. So, how exactly does Gen AI supercharge predictive maintenance? First, minimizing downtime. So, every minute, unexpected equipment failure costs money in halted production, idle staff, missed deadlines, right? So, AI helps eliminate that surprise factor. It alerts you before something goes wrong, often detecting subtle indicators that would never appear in traditional systems. But this isn't just about timing, it's also about cost efficiency. So let's break it down. AI reduces unplanned repair costs by flagging issues when they're still minor. Maybe it's a filter that's slightly clogged, a belt that's beginning to wear unevenly. It also lowers inventory holding costs by helping you maintain just the right amount of spares. No more overstocking parts that rarely fail or scrambling when a key component breaks unexpectedly. And perhaps more, most importantly, it optimizes resource allocation. Your maintenance teams are no longer rushing from one emergency to another. They're working proactively, efficiently, and strategically, right? So, in short, predictive maintenance with Gen AI shifts us from a reactive model to a resilient one. Okay, now I'd like to take some time to discuss on various industry sectors and some companies how they're using Gen AI. So, starting with aerospace, so there's this company called as GE Aerospace. They are using Gen AI to summarize dense technical documentation, and it answers engineering queries from all the employees, and it speeds up troubleshooting and error resolution. So, Aerospace is a company that's been using Azure OpenAI, which is the GPT model, um, as a Gen AI use case. Next up is an agriculture and a crop science company called as Bayer. So it simulates and optimizes crop breeding outcomes and enhances chemical formulation and testing using AI generated simulations and AI generated recommendations for farmers based on soil or weather data. Then we have the most popular industry, which is automotive and manufacturing, starting from a company called as Ford, which you all know. So it uses Gen AI in tasks such as automatically generating design documentation from specifications, then suggesting part optimizations to reduce weight and cost. Next up is Toyota. So it uses Gen AI for vehicle prototyping in tasks like AI generated car component designs and material suggestions and conversational interfaces in design tools. Then is General Motors or GM. So it's been using Gen AI for customer service and software development. Uh, it includes tasks like in-vehicle chatbot for customer support or code generation for internal tools, right? So it enhances user experience and boosts software team productivity. Then is BMW. This company uses Gen AI for tasks like AI copilots for employee Q&A then AI generated maintenance manuals and training materials, and then chatbots for customer inquiries, right? And the impact has been on knowledge democratization and reduced service time. Then is so the last one in the automation industry, which is Mercedes-Benz. So they've used Gen AI for manufacturing Q&A and production analytics. So they've included AI in tasks like detecting quality defects using AI analyzed production data, then predicts potential faults and assists in decision. So the impact has been fewer defects and better vehicle quality. Then coming to industrial automation or smart manufacturing industry, you might know this company called as Siemens. So that's used Gen AI for industrial copilot using Microsoft and OpenAI models for tasks such as AI assisted product design like generative CAD models, and to convert technical specifications into production ready models, and to support control system engineers with good suggestions, right? And they've actually even given us statistics of they've been able to reduce 30%, there's been 30% reduction in product cycle time, and the parts have been 75% lighter. Next up in this category is a company called as Rockwell Automation, which has used Gen AI um, in integrating industrial platforms. So they've used it in tasks such as real-time anomaly detection in factory operations, then AI for creating simulation models of plants, right? And the impact has been that it prevents downtime, improves safety and productivity. Moving on to the next industry, which is healthcare and life sciences. So there's this company called as In Silico Medicine. They've used Gen AI for drug discovery. So in tasks such as AI generated novel molecular structures for new drugs, and then identified a preclinical candidate for IPF in 46 days, right? And the impact that this company has had by using AI, Gen AI, is reduced drug discovery time from 1 to 2 years to just some weeks. Then we've got these companies called as AI Doc, Rad AI, and Nuance DAX. So they've used Gen AI to generate real-time radiology reports, then convert doctor-patient conversations into clinical notes, and basically it's saved the time of a physician and reduces burnout, right? Then the last but one category is finance and banking. So there's this um, company called as Goldman Sachs, which uses internal GPT-based assistant to summarize market and legal documents, automates research on companies and trends. So the impact has been it cuts the time analysts spend gathering info. And there's this finance company called as Klarna, which uses customer service chatbot that automates 2 out of 3 of support conversations. And they have this stat where they say that about 66% of inquiries handled without humans has happened by this chatbot, right? And there's been a lot of cost savings. Then the last industry uh, which I am talking about today, uh, would be retail and consumer goods. So you all know this famous fashion brand H&M, right? Even they use Gen AI chatbot like a fashion advisor bot. So the tasks that's been enhanced by Gen AI in H&M has been it offers outfit recommendations, and then it assists with size, fit, availability, right? And the impact has been that there's been higher customer engagement and conversion. Then this company called as Walmart. So it uses Gen AI for supplier negotiations and logistics in negotiating contracts using AI driven language models, suggests inventory restocking levels based on trends, right? Then is this company, retail company Zara. So they've used Gen AI for demand forecasting, where they've predicted demands for products across regions, suggests optimal production quantity, and so on. So the impact has been that less unsold inventory and more sustainable fashion. And the last categories, last company is PepsiCo. Product development, and the tasks that they've done by using Gen AI is AI generated new flavor profiles and consumer feedback simulation. And the impact has been that there's been faster innovation cycle and better market fit. All right, before we all get swept up in the AI hype, let's pump the brakes for a moment and look at the real world hurdles. So, the first one is data quality. It's the classic garbage in, garbage out problem. So, if your data sets are biased, incomplete, or poorly labeled, even the most advanced AI will produce unreliable results. So, Gen AI is especially sensitive here because it's trained to be creative. But if it learns from flawed data, it may generate outputs that look plausible but are fundamentally wrong. Next is security and privacy. So, in industries where proprietary designs, patient data, or safety critical systems are involved, leaking information even accidentally is a big no no. So, Gen AI models can inadvertently memorize and pick on sensitive data. So, that's a governance nightmare. Then there's cost and complexity. So, deploying generative AI isn't plug and play. It needs infrastructure, integration into your existing systems, and skill talent. And that talent is scarce. Also, let's not forget the human factor. So, the workforce resistance is real, right? Not everyone is thrilled about AI taking over critical or skilled tasks. So, change management is crucial. And finally, we've got ethics and trust. Can we really trust these models? Who's responsible when they go wrong? Or how do we audit black box decisions, right? So these challenges aren't showstoppers, but they do demand a responsible and a strategic approach. So, looking ahead, the future of generative AI in industrial automation is both exciting and complex. So, first, we're going to see enhanced learning systems that adapt faster, think models that continuously evolve from real world feedback. And imagine an AI model that refines its understanding of equipment behavior every time you run a machine, and it's getting smarter with every cycle. Then the next one would be a widespread adoption is on the horizon. So right now we are seeing early adopters, so those forward-thinking companies testing and refining. But in the next few years, Gen AI will become a staple in everything from maintenance to design to supply chain planning. Then there's collaboration. So, not just AI helping humans, but teams of humans working with AI co-pilots. Picture a control room where engineers bounce ideas off an AI assistant that offers real time simulations or risk analysis. And of course, ethics, as these tools become more powerful, the need for governance grows. So, we'll need frameworks that ensure fairness, accountability, and transparency. not just what AI can do, but what it should do. So the future's not just about machines getting smarter, it's about how we integrate that intelligence meaningfully and responsibly. So that is it from my end. Thank you for being here. Please let me know if you have any questions. I'll be happy to answer.
Uh, Thank you very much, Dr. Putrika, for the very insightful information that you provided to our attendees. And thank you everyone who attended today's webinar. I hope you guys learned some few things from the great Dr. Putrika. Okay, we are almost done with our webinar. Um, yes. So please join EIT's Virtual Open Week. So this is a free online event where you will be able to connect and learn from engineer professional. You'll also get a chance to explore some of the programs. I will be sharing the links on the chat box. Okay, the event is going to be from the 15th of September to the 19th of September. So I'll be sharing the link shortly on the chat, and it's free as I've mentioned. We'll be answering your questions shortly also.
Yeah, so can we have the
Some
Q&A?
Yes, I'll be sharing the questions with you shortly, Dr. Kubrick. Yes. Something exciting for our attendees. We have a competition. I think is one of the biggest competition we've ever had at EIT. Is our Automate EIT's Engineering Video Competition 2005. So basically, you just need to showcase your creativity and a humor in a sitcom style video for a chance to claim a grand prize of 2000 USD, or be one of the 10 runner-ups to pocket 100 USD each. Whether it's a clever twist or a traditional tool or a hilarious automation idea, your 3-minute skit could turn engineering creativity into a cash reward. Conditions do apply. So I'll be sending a link for that also. So if you feel that you can do this, you are able to join the competition to win the grand prize. Today's topic actually covers the following programs, as you can see. So it relates to our School of Industrial Automation, Instrumentation and Process Control. So below are some of the programs that today's topic do cover. You can also check our website and for more programs. Then our professional course advisor will be able to assist you regarding any program that you are interested in. Okay, let me just stay a bit in this so that you are able to see the programs that are offered. Okay, is everyone able to see my screen? The upcoming course section, if I may ask. So on the screen now, these are the upcoming courses for both EIT and ECT respectively. Please note the courses listed below are offered by separate institutions in Australia and the UK. It's subject to their own regulatory requirement, so you need to refer to the website for a specific location detail. Okay, so I'll be sharing the link and the QR code on the chat box. Then you can scan for your certificate of attendance. I think we can just go to a few questions that our attendees do have for Dr. Putrega. I'm not sure if you are able to see the questions on your side.
Yep.
Okay, not a
Okay.
problem. Then you can carry on the
Yes.
questions.
So first up, I see a question from Lewis, which is how can poor quality and limited availability of data compromise not only the operational effectiveness of technological systems, but also the legitimacy of automated decisions in sensitive institutional contexts? It's a very good question, Lewis. So the thing is, if the model is being trained with the poor quality data, so let's take an example of a healthcare sector maybe, and the chatbot is trying to answer instead of a physician, like it's just the initial conversation where the user is having with the chatbot. So with this poor quality or limited availability of a data can actually lead to the chatbot giving false treatment options or some faulty conversations which can actually convince user to work on something which is not good or it might be harmful as well, right? So that's one which is pretty sensitive, right? So poor quality can lead to this issue. I hope this answers your question.
Yeah, I think it can be two. I think two questions per participant. I think because I see. I think he asked about like 7 questions.
Yeah.
Louis Lopes. I think we can just two of his questions and move to other ones. Thank you.
Okay. So I see the next one is from Chris, where if we can use Gen AI to be applied in airports for baggage X-ray scanners. Yes, definitely we can use this. You know, we can train the model with the images of the explosives, even a small nail cutter, or we get this whole nail trimming kit, which is also not allowed in our cabin bags, right? So it can actually go through some repetitions of training in Gen AI models, and that's actually going to work pretty well for this. Next up is by Musa. So, if AI challenges on the slide are to occur, then who do we blame? So, there's something called as responsible AI, which is called as ethical AI. So, before we import any model or make use of any of these models, there's this responsibility that particular company who has built this model holds. So if anything goes wrong, so if something goes wrong with the GPT model, then OpenAI is the company that's built it. That's to be blamed. If you're really going into literal sense of blaming somebody, but all of these models are pretty well equipped with the responsible AI part of it. Although there are some models which you might have seen videos that are being generated online, and there's no way you can track these things, and there's no way you can actually, you know, handle the cybercrime. But there's something called as a responsible AI framework that shields with the help of cybersecurity. So we integrate cybersecurity and AI together to form this dense security wall that does not breach. Okay, so we'd be answering all the questions, right, Tony?
I think we can just ask, I think one more question.
One more? Okay,
Yeah, one more question. I think we
sure,
just
sure,
keep,
for
we
sure.
just keep.
Okay, so what is the role of the sensors installed on the production line within a predictive maintenance system, which allows problems to be anticipated and prevented by acting proactively rather than reactively? Um, so what happens is we feed in the sensor data. So we take about 6 months of sensor data of how this production line has been working. And how predictive maintenance works is, so we feed the model, the AI model, with the 6 months or 1 year of consistent data. So the model learns as to in what situation, how the sensor is giving the reading, how is it behaving, when has it failed, what are the potential causes for it to fail. So it does its own report of um, when does it fail, what happens, how can you solve it, how long does it take, uh, so what's the cost involved. So you can actually have all of these information fed to the model. And so we always say that prevention is better than cure, right? So before anything happens, we can actually use the AI predictive maintenance and foresee if there are going to be any problems with the current system going forward. And that's how AI is going to be really helpful in predictive maintenance.
Okay. Thank you. Thank you, Dr. Patricia. I
Thank you.
think, let me see if there's any question. I think you've answered pretty much all the questions. Let me see. Yeah, I think you've answered pretty much all the questions. And yes, I would like to thank you. Let me see. I think there's one more question I think that we can do, uh, which is from Musa. If AI changes on the slide, uh, if AI changes on the slide
Yeah, yeah. I think
to
I
okay,
answered
who?
that.
Oh, you have answered that one
Yeah,
already.
yeah.
Well, I think you have answered. Yeah, I think you've answered pretty much all the questions here
Yeah, they were
on
just
the
really,
Q&A
yes.
questions, because there were a lot of questions from, I think, one person, I think, which it was Louis.
Yeah, yeah, yeah.
Um,
Good
so I
questions
think,
coming from the way, Louis.
yeah, so I think, yeah, I think they were very good questions. I think we are done with today's webinar. And I'd like to thank you once more, Dr. Kutriga. And to all the attendees, I've shared some links of the on the chat box, where you'll be able to claim your certificate, our competitions, our upcoming webinars. You are able to do that. And on the screen at the moment, as I've said, is the QR code you are able to scan to claim your certificate. And I've also, yes, shared the link to claim your certificate. And yes, I would like to thank everyone for attending today's webinar. And yes, so to contact us, whether it's EIT or ECT, on your screen, those are some of the details. Or you can visit our website, and our course advisor will be able to assist you. Thank you, everyone, for joining to today's topic. It was great. And yes, thanks once more, Dr. Kodriga.
Thank you so much. It was a pleasure talking.
Thank you.
It's amazing. Thank you so much. See you.
Lovely stuff. Thank you, everyone. You have a great day.
Thank you so much.
Thank you.